Today I will show you how to use the custom velocity by the tangent. So as you can see, this car is moving by a motion path. There is a rotation on the rear tire. So back to explain what we're gonna do. Okay, first of all, I try to explain what is the basic idea behind this. So take the rotation where the car is moving, so the tires are rotating on an axis. What happen is this. So as you can see, the tangent are transforming, are moving. They don't get, they don't follow the rotation of the curve. So what we can do, take my curve. This is my compound that is the same as a normal to velocity compound, but it is called tangent to velocity. My compound tangent to velocity. So in normal to velocity, here there is a get point normal, and for curve we have get point tangent. So we get the point tangent, manipulating, rotating, but sorry, and we do what we want to do. So add the magnitude of the power of this velocity, and for preserve the information of the rotation, so the world axis become a local axis which the car is moving. We need to add a matrix transformation. So how we can do that? We do an input and add a matrix to RT, sorry, delete. Because I connected by another code. In any case, so we need this. We add matrix transformation word to a matrix multiply, add a vector 3 to vector 4 value with the axis which we wanna do some transformation, and connect to the matrix multiply. You can look, there's nothing here because we have missed the the real world transformation from the curve, and our nerves circle. So we drag the nerves circle here, add the connection to the final set point velocity, and we get a mess because we need to transform, we connect the word matrix, the word matrix from our nerve circle to our transform. So we can rename this matrix curve in, so we know what we do. So this connection is going to matrix multiply with a vector 3 to vector 4. We get the result, transform vector 4 to vector 3, and add the result that is a mat for 3 to our axis angle to quaternion. So we now have a continue update of our axis, because it taking to account the original transformation. So we can transform, we can do whatever we want to our curve. It follow every time the orientation, the tangent get the orientation for whatever rotation we can do. Back to my original scene, and I prefer to create a new graph for the transformation for the custom velocity, because it's more simple to manage. Because look at this, it's a mess. It's really complicated. We have created our custom velocity, and I have my custom velocity for each curve. So I have nerves on the left tire, right and right, left and right, that are simply parenting to the groups. Okay, now this is, yeah, okay, this cylinder have I experimenting, so in any way you can parenting to the main wheel that have that has the rotation, the keyframe rotation. Now this is not a tutorial for rigging a car, so let's continue to explain what we do. So I have a left transformation axis that work with this curve, and I have the right transformation that work with this other curve for rear velocity. And for each I have a scope with terminal. Is my scope, simple scope with a terminal, nothing special. But I have an output for each value. So what we gonna do is select and drag your Bifrost graph velocity to your new graph for simulation. So what I did, sorry, for take the velocity for each tire. I get the result from my previous graph. So we have a real left velocity and connect to the point to volume. Nothing special, really nothing special. There is a detail sides, and for this I want to explain how is important this for you. Attach a terminal doesn't connect like other. Okay, so this is rear left. Okay, as you can see here, there is a points to volume level set created for each point, and because there are many points here, it becomes something like an object, a cylinder, a torus. So this is okay. I prefer in this simulation to go to 0.2, but if you're working in another scale, I usually work in Maya in centimeters, but I import a mechanical CAD scene that is modeled in millimeters, and I don't get the transformation, the unit scale, because it's practical, because we need to update every time. What happened for you if you are working in another scale here, that the point are really little point, are tiny point, so you need to compensate, and in this case upgrade if they say the tail size to match better the scale. Because why this? This is because it doesn't work. For the custom velocity to work in this way, as you look at my video, it needs that the point size be something like the shape. Okay, so it needs to do this, but for this particular case, I can do this simulation with this the tail size. Anyway, take into account this. In any case, you need more points for curve because it doesn't work. You need to okay, there is nothing special. I set the property only to point velocity. I don't care about any other point property in this case. So let's just setting up a little bit here. So we connect the source level set to a source. That a source is a simple source A that I rename to my source velocity for each curve. So velocity left, velocity right. All together have the same setting. Relative is not important. Geovolume is not important. You can set it to shell in case it is really small, but for now it doesn't care. And the fluid detail size here is not is 0.1, and no fog density emission, no temperature, nothing. The only one that is important is the speed mode set, as mode is set, and one for inlet velocity. You don't have to set it much more, or in the case you want to control the inlet velocity, you can set this value to 111. Remember, this is something like a magnitude of our point velocity. I prefer to set it to 10, 10, 10 for each axis. Okay, so is this source velocity source A, in this case our velocity, are set like that. We have the collider, the body shape collider, the ground collider, nothing special. You can set whatever value you want. The tail size is obviously important because if the ground has a tail size that is bigger than the emitter, no emission if the collider is overpassing the emitter. I have turbulence influence, drag influence, in this case is disabled, and vorticity influence the most important. Area solver setting is set to wispy, simulation speed to 1, the gravity enable bouncy, nothing special, set to max step is set to 1 to take the velocity faster and better. Dissipation is rated 0.5 for my personal effect. And another important things are the emitter. So we have the emitter left and the emitter right, respectively this and this here. Simple shape cubes merged into the vertex here and here, nothing special. You can do this with a simple cube, it's not important. So emitter left, emitter right, the same has the same value for each solid emission. Fluid detail size now is set to 0.05. I add the temperature, but there is no combustion for now. So the speed mode is set to rate for an inlet velocity is set to 1. I control the fog density with an input value I expose to Maya is here. So from the frame 1 to frame 15, I set a range of 2000. So frame 114 the same, 150 0, so it's not emit anymore. Nothing special. This thing is simple, and for this simulation I need the voxel fog density to control my density and voxel velocity. Okay, this is it. I think you can enjoy by this video. Thank you for watching. I see you guys.